Right, so I had recorded this actually in advance because I wasn't sure whether I'd be able to get the kit to work, and I can't get the video to upload, so that's ironic. So instead of doing a high-tech solution involving video, you just get a human being talking to you. As Chris says, my name is John Ingold. I'm the narrative director of Ingold, and we're a small indie studio from the UK making narrative games. We've been going for about 10 years. It's pretty much our 10th anniversary this year. And in that time, we've made quite a wide range of games with quite a lot of little genres actually mixed in amongst them. But they've always had two things in common. There are kind of two things that form the Ingold DNA for us. The first is that we really care about the story that the game creates. And by that, I don't mean the story that the game is skinned with. And I don't mean that the story content that's sort of packaged up within the game. I mean the story that gets generated by the player as they play through the game. One of our core ideas is that there is some kind of protagonist in the game, some kind of character, and whatever the character is doing is what the player is doing, and whatever the player is doing is what the character is doing, and between them a story is told. We tend to think of it quite theatrically as this kind of improvised theatre, sort of through a computer. So that's our kind of highfalutin arty idea. The second thing that's in our DNA is that they're all built with the same basic technology, the basic underlying thing, which is the ink engine. Now, we tend to describe ink when we're trying to tell people what it is quickly. We say, oh, it's a scripting language for interactive fiction, which is a slightly strange thing for me to describe it as, because I'm pretty sure a scripting language has a proper technical definition and I don't know what it is. Like it's in a virtual machine, maybe that's what it is. I tended to use it because we're writing scripts, right? Because we're writing scripts for games, therefore it's a scripting language, but that's obviously silly. This also isn't a very good description because it doesn't really hit the point of ink for me. It doesn't really actually explain what I want to explain about it, which is that that there are loads of scripting languages out there in the world, and ink isn't really like any of them. There are also lots of interactive fiction languages in the world, and ink isn't very much like those either, because when we built ink, we sort of knew the space that existed, and we started from a very different place completely, really. And that's kind of what I want to talk about today is where do we come from and where do we get to because of that. So when we created Ink, it was right at the start of founding the company. So 10 years ago, we sort of knew we wanted to do some kind of interactive fiction. We were working primarily in the mobile space. And I personally had written quite a lot of independent interactive fiction myself using most of the tools that were out there. So I'd done quite a lot of work in Inform, making parser-based games, a little bit of work in Undum, which was a quite pretty JavaScript engine that was around about 10 years ago. And I've done a little bit of work in Twine as well. I've actually done a lot less Twine than people have. So in a way, that's the one I know least about. But having used this sort of relatively wide range of tools, I think it was fair to say I kind of developed a clear picture of what the best strategy that these tools wanted you to use for writing interactive fiction. So you're sitting down at your desk to write, you've got an idea, you want to write some interactive fiction, you open this tool, and the tool is saying to you, here is the methodical process by which anyone can generate a piece of interactive fiction. And it sort of works basically like this, that you first define the structure and the mechanics of your game, so you get really confident about that. Then you outline some kind of general flow. Then you go in and you implement the actual interactivity. And very finally, you write the words and you put the words into your game. High-level abstract idea. Let me give an example of that. So if I'm writing a game, or my structure and mechanics, okay, it's a parser game. So I decide, right, I'm going to make whatever game I'm making a parser game. So then the general flow, okay, I'll build my objects and my rooms. Inform is about building a world model of connected rooms and objects within them. So I'll build those and define them in my code. Then I implement the interactivity, right? What key unlocks what door, what's here to do that, what state I got, I implement those and I do it with my Booleans and whatever it is I need to use. And then finally, at the end of the text adventure writing process, I realize I have a stack of 50 room descriptions that I need to write. So I sit down and I go through them and I write them. And I write all my responses. And I write all the responses to the things that the player might try to do, which I don't want them to do, but which they might try anyway. And so I do this big writing job right at the end. Canonical structure of an Inform file. And you see it in the code that you write as well. It starts with code definition. definitions, and then all the text is in the middle of those in strings, wrapped in quote marks, which you fill in as you go. And you can make placeholder text and then fix it later, and a lot of people do that. For a Twine game, again, I've written very few Twine games, but the process must be roughly, you say, well, okay, up front, it's a Twine game. Mechanics, perhaps I'm using one of the standard plugins, adapting the functionality in particular ways. Okay, I make those decisions. Then I'll outline my main story nodes. I'll lay them across the graph that Twine provides for editing. And then finally, I'll interactivity of the game. So that's the hyperlinks. Perhaps fill in a little bit of detail depending on exactly what kind of Twine functionality I'm using. And then I'll go through and I'll flash actual text and put in my paragraphs here and here and here and here. So that's all very logical and all very straightforward, and it gets me to build a complete game. And there's only one problem with this, which is, of course, that absolutely no one writing IF does that at all. That isn't the process that anybody uses. Well, okay, maybe there are some people who use this. Maybe some methodical people really do think like that, but I don't know anyone who does. And as a writer, I certainly don't. My process, like any creative human being, is to start with one me and then just glue stuff to it until it's done. That's standard, right? My writing process is I start writing stuff. When I need a mechanic, I implement it. If things are getting complicated or messy, or I'm using them frequently, then and only then do I abstract the logic and write some code to deal with it. Finally, I keep writing until I stop, and that's it. That's my whole process. That is as a creator of interactive fiction. So that's a problem because it's massively at odds with the logical, coherent structure that the programming languages and the Twine story graph are asking me to have in my head. And that's not to disparage those tools. They're great tools, and I hugely enjoyed using Inform. I used it and was really delighted by what I was able to produce with it. But that's not a data point, right? It's not a data point to say that human beings can create excellent things with, because human beings are incredible. They're amazing, and they can adapt to any tool you give them. I mean, for example, the strongest example of that I know in the world is this. It's a bagpipe. It is possible to make beautiful music using a bagpipe. The bagpipe is not a well-designed musical tool by any stretch of the imagination, and yet it can be turned into a virtuosic instrument. That's not bagpipe. That's by virtue of the human being with the bagpipe. Human beings are astonishing. But for us, setting up a company, deciding to do this for a living, we wanted to, possible if we had a tool that actually worked with us rather than working for the benefit of, well, the internal data structure of the computer, because that's why Inform is the shape it is, and that's why Twine is the shape it is. What happens if we make a programming language whose first support the writer at the keyboard? What would that be like? Didn't have that higher vision when we started, because obviously we were in a panic and we just wanted to get, we actually did making a prototype. And I looked across the suite of interactive fiction tools that were available to me to write this prototype, and I needed to write up some interactive dialogue so that my co-founder Joe Humphrey. So I did a thing, which was I opened the single best editor that I had for interactive fiction, which was Microsoft Word. And that makes no sense. That's a terrible choice. Word can't even keep bullet points straight one paragraph to the next. So how on earth are you going to structure any kind of internal story logic in this piece of software? That's very much a technical first complaint. If you start to look at what Word is actually good at, you start to see why, well, actually a lot of the games industry does use Word for writing their interactive content. Well, it gives you a blank. It doesn't give you assumptions and idea what your structure is going to be. It just gives you a space to work in. Anywhere within that space, you can insert your content in the flow quite freely. You can remove and doing any restructuring, and you always have an overview of the document, and you can reorder that just by picking things up and dragging them around. It's incredibly freeform for getting your idea on the inside of you out onto paper in a way that you can manipulate. And those are really powerful features for writing, because writers don't fill them in, or at least, well, I don't, and maybe some do, but I don't. I write a few good bits here and there, throw them around, and then figure out what I need to fill in. That's just how I think. Now, obviously, I'm not actually a maniac or a Luddite, so I didn't really use Microsoft Word. I really used Microsoft Notepad, which is a far more powerful piece of software than Word when it comes to organizing thoughts coherently. Tools are all the same. So I guess what I'm saying is that the thing about programming languages is, and we were beginning already at this point to start thinking of this as what do we want as a programming language for interactive fiction? That the primary goal of a programming language is not computer to run code. The primary goal of a programming language is at the keyboard to do whatever it is they want to do. It's there so that I, as the coder or as the writer, express my thoughts in a coherent, logical, and editable way. The fact that the computer can read that at the other end of this process is good. I mean, it's important that the computer can do that, but I don't ultimately care about how the computer copes. I'm just assuming the computer will cope. What I care about when I'm thinking about the design of a language is what's my experience as a human going to be in terms of thinking it through. So I don't want to be thinking in terms of establishing object hierarchies and room maps, particularly. Perhaps I do when I'm making a text adventure, especially an old school one, which is about simulating a space. But for me, writing stories, that's not actually what I want to do. So what did we do? Well, like I say, we opened up Word and we produced something that looked a bit like this. I don't know how good the resolution is over the internet, so hopefully you can see it. But it's basically, you have labels, you have text, and the text is just text. We have choices marked with asterisks, which are, you know, the closest you can get to a bullet point in a text format, and little arrows to tell you which bit of text to go to when you've completed it. It's really very straightforward stuff. You know, you can't do anything very complicated with it. It looks a bit like a choose your own adventure book, and really it isn't much else. But that's not actually a problem. Like, that's already fairly powerful, which you probably don't believe. So I'd like to go on and justify it. But because that lets us do things already that you can't do conveniently in the other interactive fiction languages that are out there. Yeah, you're right. Right now, I can't do much in the way of functionality. I couldn't do any procedural content generation. I can't even do any state tracking with the example that I have up on screen. But what I can do is I can edit it incredibly freely. I can move content around freely. If I want to add another choice, I just do it. If I want to remove a choice, I just do it. If I want to relink the flow graph, I just relink it. If I want to make a loop, I just make a loop. All of these things which would require me to get into the weeds if I was using Twine and sort of drag boxes around and nodes and arrows, I can just do. And when I want to skim what happens in the flow of it, I can just skim through it. It's very efficient to read compared to something like Inform, where you might have scattered objects all over the place and have to work out by inference how they interact, or something like Twine, where the complexity is written on the page in front of you in a massive overview, which becomes unwieldy quite fast. The amount of complexity I can put into this script without losing my way is actually really high, precisely because it is exactly what it is. It's very straightforward. So that got us to our idea, basically, to our core idea of what we thought Ink needed to be. And Ink is a text markup for interactive fiction. I don't really think it is a scripting language. Well, maybe it is. I don't really care. But ultimately, it's a text markup. The core unit of the Ink language is English. It is written English. And what we do as authors is we apply markup to guide the computer into understanding how we intend that English to be used. So if there's an asterisk, we're telling the computer the next bit is a choice. And if there's an arrow, we're telling the computer when that choice is taken, this is where you need to go. And that gives us a fundamental concept for what our language is going to be like, which is really quite different from what other languages are. And that's what I think is exciting. So when we started, actually, I was writing this as not intended to be a computer programming language at all. I was writing this as a way of quickly getting my thoughts onto paper. Joe had built a JSON format, which is what the game actually chunked through and ran and executed. And the idea we had at the time was maybe I could write the script like this and then convert it to JSON just by copying and pasting the correct tags, just by tagging it up. So I didn't have to write JSON by hand. I could write the text, finalize the text, and then convert it over. Obviously, we did that for a bit and we realized this was a very mundane task. So we made a Perl script, which just chunked through it. I don't think that Perl script was a compiler by any meaningful definition, because it didn't produce a data structure or any internal representation of the code at all. It literally just found a string, put it in quote marks, found a choice, put it in a choice bracket. It did the most obvious thing. But it was, however, I think, our version 0.1 of our language. Now, the markup that I've shown so far is clearly not very powerful. You really can't do anything apart from a vanilla branching tree. You can branch and then you can bring it back together, and that's it. So once we'd got that down and we'd started looking at it and thought, okay, this is interesting. Where does this go? We started to ask ourselves, what can we add to this language? Firstly, what do we need to add to it? And secondly, how do we add it in a way where we don't lose that core concept of it being a text markup, not a programming language, of it being something that you can give to a writer and hopefully not frighten them off, and that fits with the sense of what a writer-based language ought to be like. So in fact, what are the core principles of it? What is the meaning underlying this simple presentation that we've got? Are we just making something that's for children, or is there something more sophisticated going on? And the more I thought about it, the more we came to this idea, which again, I want to be a little bit careful with the language, because when I say that Inc is declarative, there may be such a thing in computer science as a declarative programming language. And again, I don't know what that is, and I don't intend to invoke the demon of some theoretical concept that I don't know what it is. For me, because it tries as much as possible not to be flow based. And what that means is, to me, that when I look at a section of an Inc script, I want to be able to understand the purpose and the function of that part of the script without really needing to know the context in which that part of the script is called. So to put that in more storytelling terms, into more concrete terms, it means I want to be able to read and understand a scene in my play, in my story, and all the ways that scene can go and how it goes, where it goes, but without needing to know what the possible input states to the scene are. I want the scene to tell me by itself, for itself, what's happening in it and how things will cause that scene to go differently. That is to say, I want to make a language where I can pick a scene up and move it massively within the structure of the story, and it will still work. So that's the idea, is that I want everything to be kind of self-defined and self-reliant and modular, while still being interconnected and related. So that's starting to get very confusing. So let's have a think about how that idea plays out. So there are a whole bunch of consequences from that, and we started integrating these as we thought of them, basically. The first thing is this: all state is global. I think all the variable states are global. There's no concept of a local or a private variable anywhere in the language. Actually, in the most modern version of Inc, we do allow temporary variables that are used as scratch variables so that you can have more complicated calculations, so mid-steps in calculations. But I do think that's conceptually different than a private variable, even though in practice it's very similar. So the idea is that all the time that you set state, it's always visible everywhere in the story, and it's always accessible and settable everywhere in the story. Now, in normal programming, that's a terrible idea, because you really don't want Carol and Bob working on separate parts of the program to be attacking each other's data and miswriting and misreading it. You don't want them to accidentally use the same variable name and overwrite each other. That's really bad. But as the writer of a story, as the creator of a story, I really need the whole story to be able to understand itself all the time. I want Act 3, Scene 2 to know what happened in Act 1, Scene 4 without having to explicitly set up a pipeline for this stuff to talk to each other. I don't want to think about it as separate sections. I want everything to just be true. In the example on the screen, the player is either holding a teacup or they aren't. There is no reason any part of the story should not be able to check whether the protagonist is holding a teacup. And there is no reason why any part of the story shouldn't be allowed to let me drop my teacup or pick it back up again. So state has to be global. There's a couple of consequences of that, which are just sort of language specific things. You can define variables any way you like. There's no order of flow to where you put your definitions. And we have include files and subfiles, but they are purely for humans to file content. The computer doesn't care about where in the include structure anything is. And it's all part of that idea of not creating a meaningful hierarchy at all, as much as possible. There's a second thing that comes out of our declarative idea, which I think was an innovation rather than an obvious consequence, which is this. We aimed very much to make Booleans redundant as much as possible. That, I think, is one of the things that Inc does, which is genuinely, I think, genuinely revolutionary. One of our goals was that a beginner to mid-level Inc writer should not need to define any variables whatsoever, or even necessarily understand what the concept of a variable is. In a branching narrative, if you want something in the past to affect something in the future, and you don't want to branch the entire story off every decision, you're going to need some kind of state tracking. But what I'm saying is that I don't want Boolean variables, not that I don't want state tracking. The way that Inc deals with this is, well, every piece of content in the game has a label, because it has to have a label, because if you're going to divert the story flow to a point in the story, it needs to be able to say where it's going. So we have to label everything. It's like giving a paragraph in a choose your own adventure book a number. It's got to have one or you can't get there. So what we did was we made every single label be a state tracking variable as well. So what that means is that as soon as a piece of content is seen, the compiler understands that it's been seen, and then you can test for it having been seen later. So in the example on the screen, there's a section of content, we call them knots, but it's just a piece of content called read the book, and then you can test, have I read the book or not? And everything that happens in the story, once it's happened, has happened, and so you can test for it having happened, which is hopefully very straightforward. It's actually slightly more powerful than it sounds as well, because it means that you can branch in the future and change what happens in the future based on something in the past which did not need to tell the game that it was going to be branch worthy. That means that future John can edit the story based on something without actually asking past John's permission to do it. You can just do it. You can just get on with it. That lowers the cost of branching and the cost of including logic within your story a lot. It means you can just add branches whenever the heck you feel like it, based on whatever the heck you like, without actually doing any additional setup work. That's incredibly efficient. And it also means that you can move pieces around as much as you like. Imagine that I have this read the book condition in my story, and then I cause the actual business of reading the book to happen later in the story because I pick it up and move it. Well, okay, that conditional will just be false. The game will be fine. It can survive that kind of edit quite happily. More realistically, if I want to add in an alternative branch in which there are no books, and the player might take one and might take the other, the story simply survives. Another thing that's great about it is it's really stable, because the variables being set here are implicit rather than explicit. You can't unset them. If I've read this book, I never need to worry that somewhere in the story I've undone that variable of reading the book. As the player goes through the game, they collect things that they've turned on, and those things stay on. It's a very stable system that models what's actually happening in the game. Content is being seen. It models what happens to me when I'm trying to write the game as well. I just want to say, have you seen this thing or not? Has this thing happened or not? You'll see in the syntax for the choice there, that read the book choice. That also brings me on to the next thing, which I think is not important, but I like it a lot, which is that conditionals are not treated as flow variation. So in a normal programming language, when you have a conditional, you create a code path, you create an if block, and if that condition is true, then you divert off into this little sub bit of flow, and you come back, and perhaps you have lots of those, and perhaps they're nested. That doesn't feel declarative to me. I don't think it is declarative. So what we do instead, as much as possible, is we turn conditionals into tagging information rather than flow information. So when a choice has a conditional, that conditional is placed inside some little curly brackets, and it's inserted at the front of the choice to say, this tag is the condition that you need for this choice to be available. If you want two conditions, fine, you just put two tags on, and that's an and condition. It's not just that the game knows what to do, it's fairly obvious how the game deals with it, right? That's not clever. What it means is that as a writer, when I'm looking at that choice, those conditionals give me the context to understand what that choice is about. That's the point of a tagged conditional, is not to tell the computer anything. The computer will be fine. It doesn't care whether I use an if block or how I lay this stuff out. It makes no difference to it. But to me, the writer, it means that I can skim a whole load of choices and see, oh yeah, that's the one about the book. That's the one about drinking tea. That's the one about not having had this conversation before, or whatever. It marks up the text with information about what the text is about, which I, the human, can scan, process, read, edit, and adapt. If I realize that a choice is actually more specific than I thought it was, I can just shove another tag in. I can change the metadata on it in a functional way because I'm declaring what the state of that choice is. I'm not creating code paths for the computer to run down. It's also very good for writing what we call defensive logic, where every choice throughout a script constantly asserts these are the conditions that I need to be true, even if the flow of the game makes it redundant. So that was a long sentence. What do I mean? Let's imagine you have a companion character and you're writing a game, and every time you talk to that companion character, we'll add this choice that says, can you talk to this person right now? And what does that mean? Well, it means that should you write another path to the game in which that character can disappear or never be met, all of your conditions continue to work. You don't actually have to edit or update any of your text to make that work because your choices have already been defending themselves against that possibility. And that's what lets us do things like in our most recent game, Overboard, which is a murder mystery. There are 6 characters. At the start of the script, you could kill one of them. And by the end of the script, you could kill all of them. And we were able to do that in the space of a few days because we had been defensively tagging up all the content anyway to allow for that kind of variability. So that's that kind of comes with another consequence as well. So if we're not using if blocks, what about times where we actually just want to do, different things or produce a different bit of text or maybe branch the story based on something that happened? So normally a programming language would say, well, look, those are cases. And if you're special casing, if blocks is a good way to go. We like go-tos. Inc is a language built around the structure of the go-to or the gotto, depending on who you are. And gottos are everywhere in an Inc script. The story is constantly saying, well, if this is true, go over here, or if this is true, go over there, and jumping around the place. We very rarely use ghost subs, actually, but I'll get to that. That sounds nuts and is generally considered the worst programming thing in the world, as far as I know, but it makes complete sense for interactive fiction because the story happens on one level. It happens within the world, one thing after another in time. That's exactly what a go-to represents. If I jump from the state of being cheerful to the state of being angry, well, that's what's happened to me as a character. I haven't gone into a subroutine of anger. I've gone to anger, and there I am now, and I'd better deal with what happens next. Go-tos really describe what happens in a story much better than go subs do structurally. So they are the fundamental unit of the Inc language. And in general, although we do support if blocks and we do have them, if they get even slightly complicated, it's almost always better style to break it out into a go-to, go somewhere else and write a separate module. That means you're separating the flow information that tells the game this is how you branch and when you branch from this is the content that happens after that branch. Build the flow. Once it's done, I can get on with writing the story. That's actually quite a good encapsulation for us. Said that we don't have any subroutines or go subs in the game. I do want to stop and add that we do have functions. I'm a mathematician by training. I'm a writer by craft in that I had to actually try to be a writer, whereas maths I kind of got for free as a kid up until university, and then it got too hard and I stopped. But from the very beginning, we didn't have subroutines, but we did have functions. But we had a mathematical sense of functions. So something which performs a calculation and returns an answer. So it's not intended as a subroutine of the flow. It's just a way to encapsulate a calculation that you're doing frequently. In fact, in our original implementation of this, when Perl found a function call, it would simply paste the contents of the function definition into the code wherever it happened to be, swapping in the parameters, which is really stupid, actually. And it meant that while functions could call other functions, they really shouldn't. And if they called themselves, the compiler blew itself up, and quite often filled the hard drive with junk as well. So that was really a terrible implementation. But I think it hopes to show that we were building this very much not from a compiler first point of view. These days, it works properly. It didn't to begin with. Now we have functions that allow by reference parameters and stuff like that. The other thing I'd like to caveat on the subject of functions and subroutines is that we do actually have subroutines now as well. We call them tunnels, which is it's a weaving metaphor. So an inkle is a kind of loom. Our blocks of content are called knots, and inside them we have stitches. And when you're building a loom, you have I think it's your warp, which is vertical, and your weft, which is horizontal. And the weft is on a little block of wood called a shuttle, which goes backwards and forwards. And you lift up the warp and you put bits of it up and bits of it down, creating a tunnel, and the shuttle goes through it. And we thought, that's a nice word, we'll use that. Anyway, is used for a genuine subroutine in the story flow, because after several years of writing games, we finally started to find some cases where that made sense. Originally, it was for writing dream sequences in a game, because you could go to sleep in lots of different places, but then when you dream, you just genuinely go to the same bit of content, and you have your dream and then you wake up. So you're like Alice in Wonderland. You fall down this tunnel into your dream sequence and then you come back out. We use them a lot more now because they're actually really powerful. So for instance, in Overboard, there are characters walking around the ship, but depending where you meet them aboard this ship, you might still have the same conversation with them. So it makes sense to separate the map movement from the conversations you have with people, and tunnels allow us to do that. You meet someone, you go into a tunnel, you talk to them, you come back out, you're back on the map moving around. That said, we still needed to implement the syntax in the lowest box on the screen here, which I don't know that I've ever seen in a programming language before. So to go into a tunnel, you call it using these divert arrows. When you finish, you have a double divert, which means return to where you came from. But in exceptional circumstances, you might want to say return from this subroutine, but actually go somewhere else. So that syntax that we have at the bottom there is return somewhere else. So if you have a dream sequence in which you are killed during the dream, we can kill you in a dream without returning you to the main story. That's a crude example, but you get the idea, which is lovely. I like that the go-to still manages to rear its head, even within the subroutine context. Finally, weave, which I don't really want to spend too much of my time talking about because I don't think it's particularly on point for this particular discussion, but it's funny not to mention it because it's such a core part of what Ink does and what it is. So a weave is a particularly compact for showing branching content, and the idea is that it nests sub choices within choices and then gathers together a bit lower down. Weave comes from an idea that we started to notice that a lot of our branching flows actually had exactly the same structure. This goes right back to Twine, right? When you see a Twine graph of a story, quite often it's a funnel like this. It goes down, and it's long and thin, and it goes from top to bottom. And we thought, well, if the flow is always going from top to bottom, why don't we just bake that in as an assumption in the presentation of the language? Why do we need to divert a label explicitly or draw a line on a flowchart, say where you're going, when you're always just going down? So that's what Weave assumes. Weave says, we're going to go from top to bottom. Whatever happens, if you enter the top of a weave, you're going to hit the bottom of the weave. So it's very stable, it's very safe, it's very testing friendly. You might have a continuity error, but at least the game won't stop and run out of content. It also means that because there's a lot of implicit branching within a weave, we don't need to label a lot of the places that we divert to, or that we branch to, or that we jump to, which makes writing it a lot faster and moving it around and editing it a lot faster, and it just reduces the text on screen. So while I think Weave is an incredibly powerful feature, it has a curious position because it's not really in the language at all. I mean, it is now. When we first implemented Inc, actually what the compiler did was when it found a weave, it converted it to normal Inc, providing user like automatically generated labels, and then it compiled it again using the normal compiler. So it really did just unpack it, rather than actually compiling it properly. When Joe came to write the proper compiler that is the one we open sourced, he didn't actually know what weave syntax was because he'd never seen it, because he'd never had to use it, because it didn't exist in the final output. That's our text markup. But it is quite powerful these days. Like, I can do procedural generation with it, and we have done simulated characters moving around the map, and we've done a game called Pendragon, which is a sort of chess-like game where characters talk depending on what kind of moves they've just played on the board, which is sent in via tagging information, and then it runs a kind of filter algorithm to decide the best matching piece of text for the move that's been applied. And we have conversational engines in Heaven's Vault where characters will walk around and select the line of dialogue that they can say, which is most relevant to what's recently been talked about in the script. And all of this is done in Inc, because it turns out that you don't actually need very much programming in order to program most of the things you want to program, so long as you're willing to accept not doing them very efficiently necessarily. So Inc as a language on a higher level is one that says, well, why abstract when you can copy and paste? That, in a sense, is its true heart. Is it likes to think about coding done in terms of patterns rather than in terms of abstractions, which sounds manic. It sounds like a terrible idea, except for two things, and maybe three things. The first is that the frame rate is rarely relevant, so that's okay. The memory overhead is trivial. The second is that everything that you're programming in Inc, because it's interactive fiction, is probably not that hard, so you don't get that worried about it being buggy. Like, normally in a programming language, you wouldn't copy and paste your code, because then when you realize you buggered up this bit, you'd have to copy that fix across 25 places. But that doesn't happen very often, because most of the coding you're doing is actually fairly straightforward, and it's relatively easy to get it right. And the last thing, what's the last thing? I lost my thread. What's the last thing? Well, anyway, it's great. Oh, yeah, that's it. Because you're writing a story. Sorry. Because you're writing a story, it's very common to find that you want to insert a special case exception to every instance of everything. So, for example, if you wanted to have an inventory of objects and each object has an item description in it, you might say, well, that's a good case to have an array of strings, and that would be a perfectly valid way to do it in any other language. But then if you want one of those objects, just one, to be able to vary its textual description depending on context. So you could say, well, this is the precious necklace, or you could say this is Auntie Amelia's precious necklace, but only if you know that it is. Well, it's very easy to do that in Inc because there are no functional arrays of strings. There's only a function that returns a line of text, which is actually just Inc, and it can do whatever it likes. So this method of copy pasting code means you can add exceptions very easily because you just put them where they go. And it's not classically good programming, but it works incredibly well in this particular domain. So I wanted to talk a little bit about the things that Inc doesn't do, because Inc is quite weird. It has gotos, not go subs, global data, not hierarchical data, automatic state data that you don't actually use or specify. These are all very strange ideas. It has weird gaps in it, things that we just haven't implemented because we just haven't needed them at all. As it turns out, we don't have any arrays. I've never found a use for an array. People keep asking me for arrays now since we've open sourced it, but we tend to say, well, give me a use case, and they do, and we say, well, here's a way you can do that that doesn't require that job, doesn't require that bit of functionality. But one thing we did add that we did need was a system of flags. So this comes right away from an Inform 6 extension that I used when I was 20, written by Adam Kadra, I think. And it's if you want to store up a lot of binary values, a lot of Booleans, you make a number which is equal to 1, and a number which is equal to 2, and a number which is equal to 4. Sorry, I've written 3 in that slide, which is obviously wrong. Apologies, cherry should be 4. You add them up to make an integer, and then you can test by saying, does this concatenation of binary values contain this particular binary value. And you can do some maths. And that's not an array. What is it? It's an enum set or something like that. Anyway, we formalized that idea into what we call a list, which is not a list in the C# sense, but we couldn't think of a better name for it. So we called it a list, and that confuses everybody as well. And every value in a list has a name, it has a value, and the list itself is a variable in which you can remove and you can add and remove individual values to that list variable. Lists are astonishingly powerful, actually, and we're still working out all the things that we can do with them. So we use them to model knowledge in Heaven's Vault, so people can have a running idea of what they believe about the world. And it really does boil down to defining a large number of constants and then turning them on and off in different permutations and testing for intersections and things. But actually, that turns out to be a really powerful thing to be able to do. We use them for things like inventories, and in the chess-like game I mentioned earlier, we use them to tag up the moves to decide what kind of move have you made. Well, okay, what attributes has it got? Those attributes are list states, and we check for different permutations of them. As you'll notice from the example on screen, they also have a integer value assigned to them, so which allows you to do some tricks, though actually I find that I haven't used that feature as much as I would have expected. So that's interesting. The other thing we haven't got is loops. We don't have any loops. We don't have a for next or a while when or anything like that. Of course, we don't actually need a loop because we've got gotos, and you can very easily build a loop out of gotos, as it turns out. So we just never needed to. And again, like, that does seem ridiculous, except that it's not actually that much longer to write than a for next loop would be anyway. And you don't need a break statement, and you don't need a continue statement, and you don't need to worry about modifying the collection that you're enumerating over, because you're just literally telling the game what to do at every moment. In a sense, it's just very declarative. Another thing that's even worse than that is that when you start doing loops within functions, one of our rules is that a function isn't allowed to do any diverts, mostly just to help, well, to stop calling a mathematical function from causing the story to go somewhere else, because that could get quite confusing if you made a mistake. But then you can't build a loop in a function, except you can, because you can use recursion. And I love the fact that I'm doing a talk about writing a human-focused, writer-friendly programming language in which I'm recommending recursion, because if one thing is supposed to kill people when they're learning programming, it's recursion. I mean, I'm pretty sure there was a Star Trek Next Generation episode where they used recursion to defeat the Borg. So what chance does a writer have? But nonetheless, if you are recursing through a list structure, actually it's really efficient. So here's an example on the screen where we have an inventory list, and we want to print that list as a nice set of English strings, and you simply recurse through it. You just recurse, passing in the sublist each time, taking one off the top, printing it out, and printing out the next one with the correct punctuation between. It's a very short piece of code. And once you get used to using recursion, it's pretty readable. I don't know, I quite like it anyway, though I appreciate that it's probably not the most popular feature of the language. So I think, wrapping all of that up, say, I think it would be fair to, I mean, I appreciate I'm talking to a spectrum of people here from different backgrounds and different, experiences, but it'd be fair to say that Ink is probably a terrible programming language. The list of things that it can't do is obscenely long, and even within the domain of making interactive fiction, it's fairly easy to come up with types of interactivity that are very difficult to implement, or that the only way to implement them is in a completely bananas way. We recently shipped a game which had a system of relating list items to other list items, which was borrowed from Inform 7's relations concept. So you can say things like Poirot suspects Hastings, and who does Poirot suspect, and who is Hastings suspected by? Our implementation of that turned every item pair into a unique integer, and then stored that in a list of integers, which required about 90,000 keys in that list, so that we had each integer that you needed, which you could then turn on and off to say, does this particular pair exist in the world model at the moment? That's obviously stupid. We then improved that. We optimized it by having the game code take each item pair and construct a unique integer and store that in the save data, which meant we didn't need as many keys, but it was still a dumb way of doing it. Our most recent version of the same code turns it just into a string, sticks them all in a long string, and then uses substring operations to say, is this particular combination of states set? But I don't care. It doesn't matter that that particular substructure was difficult to program or is done in a bananas way. In the very final analysis, if I need something that's pure functionality, that's pure code, Ink is built as middleware. It can drop back to game code, return results, and then carry on going. There's always a way to solve the implementation problems that one comes across because you have access to a real programming language, C#, JavaScript, whatever you're building in. That doesn't detract or really even touch what makes Ink powerful. Because I think I go back to my days of writing parser-based games in Inform 6, and Inform is superb for setting up object relationships and for creating puzzles about putting things inside other things and moving things from one room to another. And people would build whole spaceships with doors and crates and pulleys and carts and whatever they would have. That stuff is very rapid and it's very satisfying to implement in that language. It's very easy to put a character into a scene in Inform. But as soon as you want to talk to that character, Inform becomes instantly impossible. There are verbs for conversation in the standard Inform parser model, but there's no decent state tracking. There's no sense of time passing. There's no sense of continuity. Every dialogue option is available all the time from every point, because that's how an open world type model works. Building a quick dialogue exchange in Inform is really actually an enormous labor, and largely people just don't do it. And that to me is the point, because for a writer, that's completely the wrong way up. The thing that should be easy for me is to have two characters sit in a room and have a conversation. That ought to be trivial. I ought to be able to simply do that with no effort or cost whatsoever, because that's actually the heart and soul of what my job is day to day. That's what the human being at the keyboard is asking the computer to do. And if moving from room to room is a harder thing to implement, that's fine, because I only need to implement that once. And once I've got it right, I know I've got it right, because it's easy to define what the goal is. It's easy to say what a good version of that and a bad version of that looks like. Object-oriented world modeling is actually very efficient to design and very efficient to implement. But writing conversations, writing plot, making stories happen in the right order is so far from being a solved problem that it's not even a properly defined problem space. And that's where we need the tools to be on our side. That's the part I need to be flexible. That's where I want the tool to get out of the way and allow me to be as fluent as possible, as fast as possible. I need a tool that just lets me write and that keeps up with me, because I'm doing the work here, actually. Implementation of objects and rooms is fine and it's fun, but it's not hard enough to warrant an extremely powerful piece of software or an extremely powerful piece of hardware to help me do it, because ultimately I could do it with pieces of paper and it would be fine. So I think the thing that I'm saying is that programmers become fluent in whatever language they use, because they're humans and because they practice. But a lot of the time, fluency is really just a question of knowing the answer before you've started. You're just saying, well, okay, I'm fluent at solving quadratic equations, but that's because, you know, they haven't changed in 30 years. So of course I'm fluent in them, because they're still the same problem they always were. But a tool for writers, well, ideally a writer doesn't use it the same way twice ever, actually, because they're constantly trying and exploring new things. Writers are supposed to be explorers. They're pushing the frontiers of what they're doing, not just repeating the same. There are definitely writers who make careers doing that, and well, fair enough to them. So that's what I wanted, and that's what we got, I think, with Ink, is a language that's great for the uncertain and the fluffy and the vague and the human part of my brain, and the programmer part can just get on with it because he's fine. He didn't need the help in the first place. To me, is what makes this a tool for humans, and that's what makes it my favorite programming language to use, even though I've used a whole bunch of them. Because if I want to sit down and just get on with making a story happen, Ink gets out of my way. And I love that about it. That's what I wanted to say. QR code is because, wow, look, I can make a QR code, and that'll take you to download Ink if you haven't seen it before.